Welcome back everyone. In the previous tutorial we saw how to train the network before putting it onto the FPGA. The last step that we need to perform is to select the optimal number of bits to assign to each parameters of the network. So if we start by looking at the directory in which we are working, we said that we previously exported the state dict of the network. So we will start from the trained state dict to optimize our bit widths. Let's remove the training part so we can import the state dict in order to save time. And we can do this using PyTorch functionalities, so with torch.load the dictionary that we exported before. And then we can load the state dict within our software model of the network. We need to import Torch in order to use its functionalities. Let's run the script to check if everything is okay. We see no error, so the import was successful. Let's now start to work with the optimizer. So we need to include, also in this case, the corresponding component, which is called optimizer from Spiker Plus. As we saw in all the previous tutorial, we can then instantiate the optimizer, calling the corresponding object. And the optimizer expects to receive in input the software description of the network, so SNN, the dictionary of configuration, because it will work on these configurations, and then we will need to specify the range in which the number of bits will be searched by the optimizer. So we need to specify the minimum amount of bits that we can accept and the maximum amount of bits. And we will do this for all the parameters that we need to optimize, for which we need to optimize the amount of bits. So for the weights, let's select a minimum of 4 bits, of 6 bits, and a maximum of 8. The same specification must be provided for all the parameters, so let's do the same for the neurons. Since the neurons membrane potential integrates all the weights, we will search the bit widths in a slightly larger range with respect to before, so 7 bits as a minimum and 9 bits as a maximum. And then we also need to specify the amount of decimal bits to put under the dot in the fixed point representation. And in which case we will search optimal values between 4 and 6 bits. Now let's instantiate the optimizer. The optimizer expects to receive in input a software description of the network, the dictionary describing the network since it will work on its parameters, and the ranges of search that we just specified within the optimal dictionary. And then when we instantiated the optimizer, we can perform an optimize step. This step want to know the set of data on which to be tested, that is a test loader in this case. Running the code, you will see the optimizer prints all the informations about all the values that it will search, and it will perform a grid search between these values, so trying all the possible combinations, and at each combination it will print information about the loss of the network and the accuracy. At the end of the grid search, the optimizer will print a table which contains a recap of all the combinations associated with the corresponding loss and accuracy. You can see that with 6 bits for the weights, 9 bits for the neurons and 5 bits for the fixed point decimals, we already obtain a good 93% of accuracy.